All right, we were doing some more stuff with the roots and radicals in chapter 12. Doing 12.3 and 12.4 today. And 12.3 is on combining radicals. So, if we have something like 3 square root of 5, and we add to it 4 square root of 5, this is a lot like 3 apples plus 4 apples. Just because there's a square root there, as long as the thing is the same, it's just like apples and apples. And what would we do when we got apples here? We would add the 3 and the 4, right? We're going to do that here as well. We can add the first 2 numbers together. And we end up getting 7 square root of 5. It very much requires the radicals have to be the same. Must be the same to combine them through addition and subtraction. Welcome. So happy you two could join us. Welcome. So happy you two could join us. Fucking did it again. I waited to see that bag go down before I cast judgment. All that fucking crying for 12 weeks. I need my glasses. I need my. Did you wear them? You wore them one day. Get your shit together, girl. So when we combine radicals, they have to be the same, and we can for addition and subtraction. So if I've got like a times the square root of b, and I add to it or subtract c square root of b, I get the a plus or the minus the c times the square root of b. Kind of like I did up here. If I had done the minus sign, obviously that would have been a little bit different. Only because the answer is different. I would have had 3 minus 4 square root of 5 and gotten negative 1 square root of 5, or just negative square root of 5. So let me give you guys some to do.
So we have to tell you, for tutoring, or you're just there to.
I'm going to be there pretty much every Saturday and Sunday at the Starbucks in Tahoe, in front of Tahoe Joe's at Caldwell and Demery, from 8 to 11 in the morning. If you'd let me know ahead of time, like even just an hour before, like you like. Hit me up on Discord or text me or something, I will know to see the chair. Cause sometimes, like especially on Sunday, the church crowd comes in and all of a sudden we're fighting for chairs, but if I got extra chairs sitting at the table, I'll say, nope, someone's coming. So. But generally, it's not a problem if it's too packed. Like last weekend, someone showed up and had to sit at another table for like an hour until the place cleared out. But if you don't bring your glasses, I'm not gonna fucking talk to you. I can make her wear her Nate. So the ones we can combine together, all the 10s can go together. And I'm putting the numbers out front, but if you want to just do them without putting the numbers out front, and knowing what they are, that's fine. I can also combine, I grabbed the wrong one. That's a +2. I can also put the 2√5 and the 7√5 together. So I've got 4 minus 3 is 1, and 1 plus 2 is 3. And I've got 2 minus 7 is -5√5. And I don't need the plus and the minus there, so if I want to make it look better, I'll just get rid of the plus. Did you guys get that? Anyone? Yep. Do you even listen to their music? You do? No shit.
Songs came up on
What?
Easter.
Way too young to know that. Listen to the Rolling Stones. That's fucking awesome.
That's like it.
The B17. The enemy.
Just disrespected.
No, I just.
Flat out fucking disrespect.
What are we saying?
Just make her buy your beer and you're fucking good.
First, I was 19, now I'm 17, and I told you 8 times.
She doesn't even know who the fuck you are.
Fuck it. Just acquaintance.
You guys ready? I don't know if you guys are just friends or not. I assume they're just friends, but when I leave, they're always standing next to each other, right next to a car. It might be boyfriend and girlfriend, but I don't think so. I don't think Nate's like, I ain't going for no 4 eyes. Yeah, yeah, Thunderdome right there, baby. All right, let's do another one. But now that I know she doesn't know your fucking age, clearly not boyfriend, girlfriend.
Yeah. Going full.
If you're just friends, yeah, that's normal to not know each other's age, but if you're boyfriend, girlfriend, you should know each other's age. You make her buy you alcohol,
That's why.
that's why you fucking know her. I'll have to find a way to delete that from the video. She didn't actually confess to doing any crime. You just accused her of it.
Yeah.
How you guys doing? What goes together here?
So I got parentheses 5 plus 3. And then. I don't want to say negative.
-8 or -8?
And then
What?
oh yeah.
You do not.
No.
No, the -3 does not have a square root of 3 with it. So it has to stay separate.
Or just supposed to add.
I know, that's why I threw that shit in there. Make it a little bit different. So I get 5 plus 3 is 8, -8 is 0. I got 0 root 3 minus 3. What does that equal? That part equals 0, yes. All we're left with is the -3. So if it doesn't have a radical, you can't combine it with something that does have a radical. And to combine radicals, they have to have the same thing underneath. How's that? All right, let's kick it up a notch. Sometimes we need to simplify radicals first, if necessary, before combining. For example, 3 square root of 27 plus 4 square root of 3. This is going to be very dependent on how much you remember from Monday.
Not much. I agree. Sorry.
So 3 is a prime number, it doesn't get any smaller, but 27 is 3 times 9.
I'm a little confused. Are we doing root or are we doing the, what was the other one?
The symbol is called the radical, the square root is the operation we're doing.
Right. It's because, the 3 is supposed to be on the radical, right?
No, this is a number in front of it. This is like saying 3 apples. This is not cube root of 27. Excellent question. That's why I put that little edge there to make it clear that it's in front of it and not on it.
But when it's on it.
When it's on it, it's a cube root rather than a square root. Good question. Well, this is 3 and square root of 9 times square root of 3. And what's the square root of 9? What two numbers that are 3?
Oh, yeah, that's,
So I have that 3, and then the square root of 9 is another 3. And I still have that square root of 3 still there. In hindsight, I should have chosen a different 3 up and did like a 5 up front. Because now I got too many fucking 3s there. Well, this is 3 times 3, that's 9. I have 9 square root of 3 plus 4 square root of 3. These are the same radicals, so I can add the two numbers in front together. 9 plus 4 is 13 square root of 3.
So
What do you mean always?
just only in this equation.
In this one, yeah.
So you multiply 3 by 3, not because 3 by 3 is 9.
If this had been a 5 out front, it would be 5 times 3 out front. Maybe the next one will help a little bit with that. Let's take a look at the next one. We have 7 square root of 8 plus 5 square root of 12. All right, so I don't know what they are, so I need to start breaking numbers down inside the radical. 8 is 2 times 4. And if you see a number that is a perfect square, stop factoring there. 4 is a perfect square. So square root of 8 equals square root of 2 times 4. And that's the square root of 2 times the square root of 4. What's the square root of 4? 2. So this turns into a 2. So I put that out front, and then I still have square root of 2 left. So square root of 8 equals 2 root 2. Now we'll do the same thing with square root of 12. Let's break down what that equals. Square root of 12 is 4 times 3. And 4 is a perfect square. Shit, there we go. 4 and 3. 4 turns into a 2, and the square root of 3 stays the same. This turns into a 2 square root of 3. Now, unfortunately, the radicals are different, which means we're not adding them together. But we've at least simplified it some. If we multiply this together and we get 14 square root of 2 plus 5 times 2 is 10 square root of 3. Emily, you like the songs? It's awesome. Sympathy for the Devil is one of my favorite songs. Just because good Catholic and Christian people hear it, they just fucking hate on it and think I'm a devil worshiper. And I'm like, fuck you guys. I don't worship the devil. The song's just good.
Have you
Yeah.
heard Dancing to the Devil?
I want to say I have it. I don't know who sings it.
Don't hear it.
Sounds like a Marilyn Manson song. She making shit up.
No, actually,
Like, it's not really-
What she's doing is she's playing delay of game. Fucking know this song. You play this song every day.
I am not gonna. Lose. It's that like Bruce song.
All right, so that was the final answer on that one. Doesn't get any smaller. But it is a better answer than what we started with. Let me give you guys one to go with and see what you guys come up with now that you watched me working my mojo.
What's up?
Oops,
It's a movie, huh?
just a reason to not just play on the phone and not do the math.
Not even. I actually want to know who he's Dancing to the Devil. So. Can you show me?
Back up. Yes, we will use that as a sample platter.
Immortal technique. I have to advise you to figure it out.
Cleaning it up. Ready, Bertha? Are you still working on it? So where, let's see where you're at. Who's done the problem? I know Bertha's still working on it. I know Ariana hasn't even fucking looked at the screen. I know you haven't, you fuck planner
I
now.
did the, 9 times 5,
That is a 9 times
and
5.
then 5 times 3, and then the square root of 5.
So 5 times 3, yes,
And then that will be 15, and then the root of 5.
that's the first part.
The other part, 2 times 10.
Can you break down 10 further though?
5 times 2.
So if I put the 2's together, I got 4 times 5. And 4 turns into a 2. Square root of 4 turns into a 2.
Take the 3 from the 9. Square root of 9.
Yeah,
Okay, 5 times 3.
so this is minus 12 square root of 5. So we should end up with 3 root 5. Because now these are the same, so we can put the 15 minus 12 together.
Yes. I'm thinking. Of 3 times. Yeah, 3 times.
You guys want another one like this?
Yeah.
Are you good with where I lost you, Ariana? Other than at the beginning when you're on your phone.
You can look on my phone, I have a multiplication chart.
You do now,
No, I actually have it.
the whole time, okay, right?
Anyways, I'm kind of lost at, the third step.
Here?
Yeah.
So we did 5 times 3 to get the 15, 6 times 2 to get the 12. Now, these are the same thing, so this is like saying 15 apples minus 12 apples. I do not know why apples is my go-to fucking object. It should be like chocolate chip cookie or some shit like that.
And then you got 3 times 5, which is 15,
Yes,
and then now this one.
and 6 times 2 is 12. So these two are multiplied together and these two are multiplied together, which means there's a multiplication sign between all this shit. So 5 times the square root of 9 is really 5 times 3. The square root of 9 is 3, so I got 5 times 3 is 15. And I still have the square root of 5, I couldn't do anything with it. So it just stays here. It's like baggage. That make sense?
Yeah.
All right, so we get 3. You guys want another one like that? All right, let me see what I can come up with. Let's go with. I think you've inspired me though. This is for you, Ariana. Got rickrolled. You know how old that fucking song is? It's older than everybody but me and Bertha in this room. Yeah, I looked up when that song came out. It came out in fucking 87. Fucking 87. I was a fucking teenager when it came out. No, no,
So you were
I did not have a teen in it. There was,
10.
I was 12.
Started in 28/7.
It's 4 times 7.
That was just one.
But it would be.
Oh, shit. Let's make this a 63 over here. This is what happens when you make shit up on the spot. Never gonna let you down. Okay. So what can we do with the 28?
So, times the
4 times 7, so this is 3 times square root of 4 times square root of 7.
and plus 5 square root of 9 times 7.
Yes,
And then 3 are the root of 3, and then that's where. I'm confused.
what's the square root of 4? 2.
And then
What's the square root of 9? So now I can multiply the 3 and the 2 together. And I get 6. I can multiply the 5 and the 3 together and I get 15. And I add these together and I get 21 square root of 7. Good. So we're done doing the addition. Let's do some shit. Now that you're like, yeah, I think I got it. We're gonna go on some other shit. You're gonna be like, why did this shit change? So notice with addition and subtraction, when I put them together, what I started with, I ended up with inside the radical. That rule changes when we do multiplication and division. As we really just used up here going the other way. If I take square root of 4 and multiply it by square root of 7, I get square root of 4 times 7, which is square root of 28. We went the other way right here. So when you multiply two radicals, with the same index or same root, you just multiply outside times outside and inside times inside. So if I have a square root of b and I'm multiplying it by c square root of d, I'm left with a times c on the outside. Those are my two values outside the square root. They stay together. And on the inside, I have b times d. Those go together. So there's my inside times inside, and there's my outside times outside.
And that's inside times inside.
Yeah. Like we did here, 4 times 7 is on the inside. We haven't multiplied anything where it was on the outside yet, so let's take a look at doing that. If I have 2 square root of 3 times 3 square root of 5. What that gives me is. Let's make that a 7 out front. I don't want any confusion on where the numbers are coming from. And I had 2 3s in there. We're gonna have 2 times 7 on the outside. And 3 times 5 on the inside. Two times 7 is 14, and 3 times 5 is 15. And ideally, when you do this, you want to simplify the radicals before you do it. Because it's easier now rather than later.
Before you do one.
Before you multiply them. 3 and 5 are already simplified, so we didn't have that issue here. But let's do a problem where we do.
It's because it's easier now. Rather. That's just.
If I try to do 12, okay, I could do multiply this. 12 times 15 is 180. Factoring 180 is a fucking pain in the ass. Factoring 12 and factoring 15 is not. Well, 180 is not too bad because it ends in a 0. But I can see right away, this is square root of 4 times the square root of 3. And this is square root of 3 times the square root of 5. You don't have to factor first, but it's a lot easier. So I have the square root of 4, which is 2, right? Here I have the square root of 3, but I got 2 of them. So the square root of 3 squared, which is pretty convenient. Because the square root and the square wipe themselves out. And I'm left with 2 times 3 times square root of 5. Which means this ends up being 6 square root of 5. Apparently this means 180 is 36 times 5 because the square root of 36 is 6. But who the hell is going to recognize that? I sure as hell don't see 180 and think, oh yeah, that's fucking 36 times 5. But I see 12 and I see 15 and I go, yeah, that's 3 times 4. I can do that. That's basic multiplication. Now, you don't have to do it that way. You can do it however you want. Let me give you guys one to try.
Goes into one. Or is it 0?
What?
One goes into one or is,
One goes into one. Anything good, one,
is one,
yeah, don't mess with one. If you're going down to a one, you're going too small. All right, so. Yeah. What are on?
nothing.
Let's go with it. Let's see what you got. Hit me with the digits.
3 times 2. Oh, that's,
All right, if you want them under the rate.
yeah, I put 60
Okay,
and then I put 3 times 2.
where's the 3 times 2 go?
So I put 60 where 6 times 2. I put 3 times 2 under the 6.
I have no idea what that means.
I put, so 6 times 10, or square root, right, would equal 60.
Yeah, which is what I got here.
Yeah, but I put it there, so then it wouldn't confuse me.
Okay,
And then I put 3 times 2, and then I put it times 2 times 5.
like that? Or like this? I'm hearing 3 times 2 times 2 times 5, that's what I just did. Yeah. Let's see what we got.
Sorry, it's messy. It's the same.
How is that different than what I wrote? Why are you looking at me all fucking confused?
Because I'm confused on how you did that. I'm used
I'm
to
writing the same thing you did.
Yeah, but like it's in the wrong place.
Did you, where did you want, what do you mean did I need to write it below it? What do you mean it's in the wrong place?
Like you know how exactly the one our example.
Are you talking about this?
Yes.
Oh my god, this is what she's talking about, the arrows going down from 6, breaking it down and 2.
Damn.
All right, hold on. Let me redo this with the whole, hold on, I need to.
I'm sorry.
pause the recording for a second, so this doesn't get caught on camera. Yeah, all right, so let me redo it such that Ariana isn't going, oh, OMG, Ermiger. So. Like that?
Yeah.
You know, if I do it to the right as an equal sign, it's the same thing. Okay, this is the same thing. So I do it to the right or below it. You said 60.
Yeah.
So I wrote down what you said. This is an easier path.
I'm just going based on the example that's literally on the top.
Yeah, I know, but where did the 60 come from? You didn't.
610.
Okay, on the example up here, oh, I know what. You wanted a square root of 60 over here, right?
Yeah.
Oh my God.
And did you not see the square root? of 60?
I did not, I get it. It's very, the position matters to you. Okay, I didn't understand that. I fucking completely understand now. It's important to you for you to know that this pattern is not a ritual or a formula. I was showing two different ways of writing it. You don't even need to write the square root of 60. The only reason I showed it was to illustrate why I said simplify before you multiply. Because if I multiply first, I have 180. That's hard to factor into 36 times 5 without a lot of fucking guessing. But simplifying 12 and 5 is easy. That's all. Also important to know, this is very, very important. The arrows aren't necessary.
Well, I know that. I'm just going based on what's under and what
Okay,
equal to 6.
okay. We're good? What do we do here?
So we go to
You're trying to go too small. We've already got them down to prime numbers. So doing 3 times 1 doesn't help. So now we look to see, is there anything that's a perfect square? If I put the 2's together, I do, right? This is square root of 2 squared. And that just becomes a 2. So I can bring down my multiplication. I need to stop doing arrows. I had no idea that was the fucking focal point of why you look confused, that I didn't have fucking arrows. Never had a student say that. So that's nothing wrong with it. That's where my misunderstanding was coming from. All right, so I can't do anything with these, so now I can multiply the 3 and the 5 together. And I know with 2 square root of 15. Do you guys get that? Fucking rigrolled her and she just can't handle it anymore. Very fucking proud of that. I'm gonna start doing that every semester at least once. Next time though, it's gonna be like when we're about to do a graph, I'll be like, I'm about to put Desmos up. And I'll just fucking throw up the rickroll. Because here it was like, I told you I was gonna put something just for you. But it's better if I just said, here's a graph. And then I load up the screen and the rickroll is ready. I think that's gonna be my new move. All right. It also works when there's fractions. Now, you have two choices. I don't know if I want to give you choices. Ariana doesn't like choices. She likes a formula. Let's do the formula then. Although I haven't said it yet, the rules for division are, this is the same thing as square root of 3 over square root of 8 times square root of 2 over square root of 3. Which means when we did fractions before, if we had 3 times 8 times 2 times 3 before, we had it where we could cancel off things that are on top and bottom. Here I could cancel a 1 and I could cancel, or I can cancel a 3 on top. The same premise applies. Radicals. I've got a square root of 3 and a square root of 3 on top and bottom with multiplication, and I can cancel them. Now, we can either, this ends up being square root of 2 over square root of 8. I can either put it together and see what simplifies there, or I can reduce again. Let's reduce again. Square root of 8 is 2 times 2 times 2. That's square root of 8. So that's square root of 4 times 2. And we already saw that we can make that square root of 4 times square root of 2. Which is 2 square root of 2. That's what I'm going to put on bottom here instead of square root of 8. I'm going to put 2 square root of 2 there. I'm going to pause and make sure we got along the same page with that. Or when you kisses. I was not talking to Nate. So what can I do here?
Can you eliminate the square?
Square root of 2? Yes, I can. I have a square root of 2 on top and bottom. I can replace them with 1s. And I'm left with 1/2. Because the square root of 2's cancel and are replaced with 1s. I have a 1 on top, which is right there. I have 2 times 1 on bottom, which is just 2. Excellent question. Let me give you guys one to try. I think we might not finish chapter 12 today, which means we might finish chapter 12 next Monday, do the review on Wednesday, and do the test the following Monday. Which gives you extra time to actually do the homework. Why are you looking at me like that's a fucking bad thing?
That's me.
You'd rather have your test Wednesday?
It's on the final one.
No,
Oh,
we're 6 weeks away from the final.
yeah.
Slow yourself down.
The one test.
Another class, and then I have to go to some.
Did I say final?
No, you just said test. What's
No, I
next?
said I.
We were gonna have a test next week is what, I talked about it yesterday on Monday,
Yes.
and there's an announcement about it. Y'all don't check fucking Canvas.
I did. Oh, well, I have it in like a week, I think.
We talked about it on Monday. We were gonna finish chapter 12 today, we were gonna do a review on Monday and do the test on Wednesday.
What kind of test?
The one on the chapters 7 through 12.
Now.
Because you already did the test on chapters 1 through 6.
Then I was gonna finish chapter 12 on Monday.
So yeah, now we're gonna finish chapter 12 on Monday.
Review Wednesday.
We'll do the review Wednesday and the test will be the following Monday.
Then that was the midterm, right? We took for chapter 6.
If you want to call it the midterm, sure.
That's what you guys said.
I never use the word midterm. Mine just says test.
It's a midterm.
What?
It's a
On Canvas? Let's go take a look at that. I'm calling bullshit.
So then chapter 12 is not due on the 14th, then it's gonna be due until next.
Yeah, we're gonna push it. All right, so let's just put it up on the screen. Make sure everybody's on the same page.
Okay, so.
Never gonna give you up, never gonna let you down. Wait, do you guys see how many courses?
Yeah, I see.
Did you see that? Go back to my dashboard. Look at that. Holy shit. How many courses is Jones in? SETA is actually not a course, neither is MESA, neither is Academic Senate. The rest are courses I am either teaching or one I'm actually sitting in on and learning. All right, back to what matters, you guys. You guys are what matters, right?
That's what.
Wait. So it says next test and review date. All right, so we are a week behind schedule, which is fine, as I was being a bit ambitious in what I thought we could reasonably cover. We'll be doing chapter 12 this week. Next Monday, April 17th, we'll do the review, and Wednesday, April 19th, we'll do test number 2. I don't see the word midterm anywhere, but let me go look at this syllabus thing right here. I don't see midterm. I see test on chapters 1 through 6 here. I see test on chapters 7 through 12 there. Again, I don't see the word midterm anywhere. I call bullshit on your guys' delay game tactics. Very good. Let's finish 12.3. That was all to get out of doing square root of 5 times square root of 10, isn't it? Go ahead and do this, Ariana, real quick. If you want to do it out loud rather than on paper, walk through it verbally, let's do it. Or you can do it on paper first. It doesn't help you any. Sure. When? Sure. Yeah, we're gonna do the review on Wednesday, so if you want to do it Thursday or Friday, I can make range.
Yeah, it's in the circle.
No, I'm not showing it again, but everyone saw that there was no midterm listed anywhere. I call bullshit on the delay of game tactics. I assume that's your calculator and you're not scrolling through fucking Instagram, your TikTok fucking channel. Looking for your sugar daddy.
It would be, it would only be like. What?
All right, so this, the 5 doesn't get any smaller, right? Does the 10?
Yeah.
I'm not gonna do the arrows. Can you handle this? Are you good with that step?
Ducking.
Felt a little moist. No, it didn't. It really didn't, but I knew if I said that out loud, I'd fucking get a reaction. I know, moist is just, there's not really a circumstance where moist is good. Like, a moist cake is theoretically good, but everything else with moist is generally bad.
Moist cake is a good.
Yeah, well, you've had cake that's like fucking eating like a biscuit. That's fucking just, but a moist cake still has enough where it's nice and soft and, you know, cakey. That's called a moist cake. All right, so what can I do here? Yeah.
The 5, you're gonna do, parentheses, 5, square of 5. Close parentheses, Q, the top, times.
Square root of 2, but yeah. So what does that become?
5.
Good job. I'm going to attribute it to you. From now on, every semester when I rickroll students at least once, I'm going to say I had a student cast and do a delay game multiple times in the 2 hours. Finally, I hit her back with my own delay game. Back and rickroll the rats. And then I realized I could do this every semester with every group of students. There's always at least some point I need to go and put the fucking computer on the screen. So I can do this at any time, anywhere. I could tell you that I'm going to give you a formula sheet on the test. Say I'm going to put it up on the projector. And then instead of putting up the formula sheet, just rickroll your ass first. It's just
Does it every time?
so fucking good. All right. So that's how we do that shit. Sometimes we have more things going on. If we have parentheses involved. I cannot combine the square root of 5 and the square root of 3 together because they have different values under the radical. So there's nothing to be done with that. I can, however, take the 5 and multiply each one of those or distribute. And I get 5 times square root of 5 minus 5 times square root of 3.
You're gonna eliminate the 5, right?
No, that's a done deal. That's the answer right there. Nothing else can be done.
So you cannot, you don't take 5 away from the minus.
No, because they're both multiplied by different things. This is like saying 5
Oh, that's
apples
true.
minus 5 oranges.
That's-
That's an excellent question. This is like saying 5 apples minus 5 oranges. It doesn't do anything.
Only if the inside of the square root was the same.
Yeah, it's gotta be the same thing. Now, I had a 5 out front, but I could very well have a radical up front. I could have square root of 2 and multiply it by square root of 7 minus, I don't know, 2. When we do that, I distribute square root of 2 times square root of 7. And then I've got a minus square root of 2 times 2. Here, we just saw that we can put these together, right? That becomes square root of 14. We just did that. Here, I can't do anything with it, but I can put the 2 at the end in front. Which is a cleaner way of writing it. Let me give you guys one to try. Square root of 3 times square root of 7 minus square root of 5. I'll like type up a new note about how the test is gonna be. Who's gonna help me on this? Close. Close. So there is sets of multiplication here. There is, that ends up being wrong, but it's close. We're gonna take the square root of 3 and we're gonna multiply it by the square root of 7. You're literally taking it and multiplying it by each thing inside. Yeah. Now we can multiply the 3 and the 7, we get square root of 21. We can multiply the 3 and the 5 and we get 15. And that's as good as it gets.
It's almost like close.
You have the square root of 7 here, and there was a 3, but it should have been a radical 3 here. And that should have been a radical 3 there. So you were close. Would you rather me say, no, that was completely fucking wrong? I can. Most people don't like being talked to like that. Because you knew there was some shit that needed to be multiplied together. You just were doing the wrong pieces. Take it slowly. Go one step at a time. Now, sometimes we have parentheses times parentheses. Maybe I should start this on the next page. Trying to see if you guys did something on it before. Yeah, in chapter 11. We did similar shit when we multiplied polynomials. We would distribute one thing at a time. I'm going to do the 5 times the square root of 7. Then I'm going to do the 5 times the minus 2. And then take the square root of 2 times the square root of 7.
Why isn't it? Minus 5 times 2.
Because there's a minus here.
or minus 2?
I could say plus 5 times negative 2. Doing this is the same thing as doing that. This helps better. Please do this. The plus and the minus kind of overrides the plus. And then finally, I gotta take the square root of 2 and multiply it by the 2. I'll do that, I'll do it with you on that one. This doesn't do a whole lot of cleaning up. Once we're done, we have 5 square root of 7 minus 10 plus square root of 14 minus 2 square root of 2. So to take each, they just go one at a time. Start with one parentheses, take the first thing in that parentheses, multiply by everything in the other parentheses. We did this very thing when we had like x plus 3 times x minus 4. We did this back in chapter 11. Which was before spring break. And we did the same thing, we multiplied the x times the x and got x squared. Then did x times the negative 4 and got negative 4x. And then did 3 times the x and got plus 3x. And 3 times the negative 4 and got minus 5. We're doing the same thing here, but there's radicals and not x's. Well, you get to do both. Chapter 11 was with the x's. Okay. We're gonna do the same thing with more, let's do some more practice with the radicals. She's ready. Let's do it. Y root up there.
Because. Because.
Only put a root there if there's already a root there. Does 4 have a root? No.
Well, plus 3 times 4.
Which 3?
Root. The root of 3 times 4.
That's true.
Plus. A root of 3 times a root?
Nope,
No,
we don't have a root of 4 anywhere.
plus 3.
We're not gonna add it, we're gonna multiply it by that one. There's one more. So this helps if you go in order. Go in order. Start with the first ones and multiply them together. We got that. It's my first ones. First ones. Then use this one and then do the other one in these parentheses. Do plus. So I got 2 times 4 plus I'm going to do the 2 times the 3 root 3. This takes care of doing that one times that one and that one times that one. If you follow the same pattern every time and don't bounce around, this will get easier. Then doing this times this is good. And then I got the square root of 3 times this. You gotta go very systematically, like you're doing a recipe. You just want to go step by step. It is possible to bounce around and do stuff that you will know goes together, but it's only when you're really like experienced at it. If you try to bounce around, you might miss shit. So I'm gonna cross that out for the scan. Almost. All right, so we keep going. 2 times 4 is 8. 2 times 3 root 3 is 6 root 3. Square root of 3 times 4, I'm just gonna put the 4 in front. And then I've got plus 3. And then I got times square root of 3 and another square root of 3. I got square root of 3 squared. We can keep going. I can't do anything with the 8 yet. I can add these two together though, right? This is 6 plus 4 is 10 square root of 3. And this actually changes too. The square root of 3 times the square root of 3 is what? Or square root of 3 squared.
It's
The squares cancel out the square. That's just the 3. This part right there is that number right there. And now it looks like there's some more I can do. 3 times 3 is 9. Right? And now I've got 8 and 9, and I can add those two together. 8 and 9 is 17. And I still have 10 root 3. All right, so. Something else we can do. Sure, we can see if we did this back then. We did. In chapter 11, we learned a minus b times a plus b is a squared minus b squared. We were doing this was chapter 11. We were doing with variables and whole numbers, but it also applies to anything. I can put radicals in here and do the same thing. If I put radicals in, I could have like a minus square root of b and a plus square root of b. This gives me the first term gets squared. And then I have a minus, and the second term gets squared. And we end up with a squared minus b. I wouldn't memorize that formula. This top one is what the idea to remember, and remember that whatever we have in the last spot gets squared, and we'll remember whatever we have in the first spot gets squared. So we could have things like 3 plus square root of 6 times 3 minus square root of 6. You can always do that distributing thing, and it gets the same thing as this shortcut. But this shortcut is a lot quicker. This gets us 3 squared minus square root of 6 squared. Three squared is 9. Minus square root of 6 squared is just 6. And it goes to 9 minus 6 is 3. What if we have a square root in the first thing? We've got 3 square root of 2 plus 1 and 3 square root of 2 minus 1. It's following the pattern. I got the first things are the same, the second things are the same, and one's plus, one's minus. I can do 3 square root of 2 squared minus 1 squared. The square applies to both of those. This is 3 squared times square root of 2 squared. Minus 1 squared is just 1. Three squared is 9. Square root of 2 squared is 2. We do order of operations here. The multiplication becomes before the division. 9 times 2 is 18 minus 1. 18 minus 1 is 17. Well, we did one with the square root at the end. We did one with the square root at the beginning. Let's do one where the square root's in both. Let's do square root of 3 plus square root of 2 times square root of 3 minus square root of 2. Same thing here. We've got the same thing in the front and the same thing in the end. And one's a plus, one's a minus. I can do square root of 3 squared minus square root of 2 squared. Square root of 3 squared is just 3. Square root of 2 squared is just 2. 3 minus 2 equals 1. Okay, check this out. We had radical here at the end, and my solution had no radical. We had radicals in the beginning.
Didn't see the.
We had radicals at the end, and there's no radicals in the answer. We had radicals in the beginning. There was no radicals in the answer. We had radicals in both spots. There's no radicals in the answer. What's handy with doing this with radicals, and you have this combination of these pairs, or the only difference is the minus and the plus, the radicals end up going away. These are called conjugate pairs. We see them here with radicals. We'll also see them in 12.4 when we do complex numbers. I think that's a good stopping point for today. Carrie Ann's eyes are glossing over. She's gonna try to distract me again, so let's just tap out.
Fine, any chance we have this study again?
The review exam is gonna be for.
Huh?
That's what a review exam is gonna be for. It'll show you what to expect. No, I don't have it already. I'm gonna work on it tomorrow morning.
We'll see if I had any questions, technically, weeks and next time.
I will, I'm gonna have it ready this, I'm working on it tomorrow morning. I don't have anything else to do tomorrow morning.
If not, that's,
Well. What?
I said if not, that's okay.
If you're going out of town, we can get, there's a way we can do it on Thursday. I am here on Thursday. See ya. Yes,
Oh,
total of 2 tests and a final test.
it's what if I'm doing bad on the test, but I'm like, you can see my plan. So it's just a shitty tester.
I don't know. I don't remember what our percentage
It just
breakdown
depends
was.
on,
Well, it depends on how well you're doing on the homework.
yeah,
And it depends on what our syllabus is. Let's see, what do we have as our breakdown?
Thank you.
The homework and quizzes on Math Lab are worth a total of 40%, 20% each.
and then the tests are like,
Tests are 15% each, which is a total of 30. The final is worth 30 on its own.
which is still pretty big,
It's a pretty big chunk.
yeah. Okay. Well, as you can see, I mean,
If you don't mind me asking, what makes it harder for testing? What's the,
it's for me, it's retaining all the information and the steps.